Welcome to video 6.2, converting between grams and moles of grams. In this video, we will be learning how to convert between the moles and grams, or back from grams and moles, between different chemicals in a chemical reaction. Key vocabulary terms for this video are none. There are not any key vocabulary terms, but you will need your mole map and periodic table. Grab your calculator as well and your pencil as we get started into the world of stoichiometry, the world's greatest real-life math problems. So in our last video, we learned about the mole ratio. The mole ratio are simply the coefficients within a chemical equation that we use as a conversion factor within a conversion problem. And so now what we're going to do is we're going to use our mole ratio, but we're also going to use our mole map and be converting between moles and grams between different chemicals. So if we can convert between the moles of a substance, we can now use the molar masses to convert between the grams of one substance to the moles of a new substance just as well. So here's a practice problem. I'll read the problem to you. Those of you who are feeling comfortable from the last video 6.1, pause it and try it on your own. Those of you who do not feel comfortable yet, just watch me show you how to do it with my own hand. So as we get started here, the problem reads, determine the amount of moles that are produced of both products with 654 grams of NH3 and excess oxygen. So that word excess oxygen, we'll learn more about what that means when we get to video 6.4 and we talk about limiting reactant. But basically what's saying is I have 654 grams of NH3 and I have I have excess amount of oxygen that is available to react with all of that other reactant. So for this purpose of this problem, we can just ignore this amount for now, but that term excess will become more clear when we get to video 6.4. So what we see here is it's asking me to calculate the amount of products, both products, from this amount. So we're going to have to do two conversion problems, and we're going to start both conversion problems from 654 grams of NH3. So one thing I like to do to set up my problem is I will like to put a question mark here and put a mole, because that's what I want to find my unit in. And I like to put a question mark here and a mole. And as you do more of these problems, you'll see why that kind of helps you out. All right, so we're doing a conversion problem. So what we need to do first is we probably need to go through and balance this chemical equation. So first we can pick any element. I kind of told you to start with oxygen last. So as we go through here, let's just see what it looks like. I want to start with hydrogen first. I see 3, I see 2. So I'm going to cross my numbers. That's going to give me a total of 6 hydrogen and 6 hydrogens. Now I'm going to go do my nitrogens, 2 nitrogens, 2 nitrogens. Now I see I have 2 oxygens plus 3 oxygens gives me 5 oxygens. Oh no, I went down a dark road. I'm in a dark alley. I'm stuck. It's a dead end. So now, what was the tip I gave you? Go through and double your coefficients. So instead of calling this 3, we're going to call that a 6. Instead of 2, we'll call that a 4. And instead of a 2, we'll call that a 4. Now let's go through and double check our numbers. 12 hydrogens, 12 hydrogens, 4 nitrogens, 4 nitrogens. Now I have 6 oxygens plus 4 oxygens. So since that's 10 oxygens, I can simply put a 5 there to get my 5 oxygens. So now we're ready to actually do the work. So since I want to convert the amount of product here, and I'm starting here, we're going to do step 1 in all of our conversion problems, which is write down what you know. Write down the given from the problem. The problem gave you 654 grams of NH3, so we're going to write that down first. So make sure you're following along and you're writing this down in your own hands. So step 1, write down what you know. Step 2 in all conversion problems is simply follow your units. Grams, NH3, grams of NH3. Now be careful to make sure you are also including the chemicals now, because now we are going to be not just converting between the units of grams, moles, and particles, but we're also going to be converting between the chemicals. So we need to keep and show the chemicals in the work as well. It's going to help us from getting lost. So now I've followed my units. Now I am into step 3. So in order to do step 3, get a conversion conversion factor, we have to use our mole math. So what we see is I am in grams, and I want to convert to, well, what's the only place I can convert to? The only place I can convert from grams is to moles. So I am on the same line. So these are going to be the same chemicals. So I'm going to go from grams of H3 to moles of NH3. And now I have to find that conversion problem. Well, that's called the molar mass, and that's found on the periodic table. So I can simply say nitrogen is 14.01, hydrogen is 1.01, 1.01, 1.01. And again, as a reminder, where did those numbers come from? They came from right here, rounded to two decimal places, and right here, rounded to two decimal places. I add it up, and I see the molar mass of nitrogen trihydride is 17.01. Now, I am here, and I want to convert from the reactant to a new chemical. So in order to go from this moles, I am going to convert, just like in our last video, to another chemical. See how this is another line? So all this represents converting between one chemical. All this is converting between a different chemical, and the way we relate chemicals is right here using the mole ratio, which are just simply the coefficients. So follow your units again, moles of NH3. Since I'm here and I want to go here, I'm going to go from moles to the new chemical. And now, step 3, get my conversion problem. We're going to use our mole ratio like we learned in the last video, which are just simply the coefficients. And this tells me there are 4 NH3s to produce 4 moles of nitrogen monoxide. Now, since we're converting to moles, we are finished. If I wanted to, and this is what your next video would be, if you're here, you can convert that to grams by simply following your units and converting to grams of nitrogen monoxide, just like you did here. But that will be the next video we'd look at. And so now, for this video, to finish it up, all we do is put it in my calculator. I'm going to do 654, multiply across the top, times it by 4, divide across the bottom, 17.01. And then since this 4 is in the denominator, I have to hit divide first by 4. Get my answer. I started with 3 sig figs, so I'm going to have 3 sig figs in my answer. The units I have left are mole of NO, nitrogen monoxide. Now we're going to do exactly the same thing starting here, and we're going to convert to water. So if you haven't already, go ahead and pause the video, try this yourself, see if you can walk through it yourself. And then after you tried it, press play and watch and see if you got the right answer. Seriously, pause the video and try it yourself if you have not already. Okay, those of you who have tried it and those of you who are going to ignore my suggestion, here we go. So we write down what we know, 654 grams of NH3. Step 2, I follow my units. I got grams of NH3 here. Again, I'm in grams. The only place I can convert to is moles of the exact same chemical. So it's going to be just like above. 1 mole, 17.04. Oops, that was a mistake. That should have been 04. And that's why, if you run it through, I think the answer is still the same, but that was a small mistake on my part. Sorry. All right, so now as we continue, now I am in moles of NH3, and I want to convert to moles of another chemical. I use what's called the mole ratio, and I just use the coefficients. So as I set up the problem, I follow my units because they have to cancel out. And now I'm going to go from moles of NH3 to predict the moles of H2O. Now my coefficients gives me the conversion factor. This says that there are 4 moles of NH3 that will produce 6 moles of water. Now again, since we're only converting it to moles, we are done. But if I wanted to, I could do another conversion factor, go from moles to grams of water. Again, we'll see that in the next video we do, 6.3. All right, so as I go through here, I put this in my calculator, 654 times it by 6, and then divide across the bottom, 17.04 in this case, and divide by 4. 3 sig figs. 3 sig figs in my answer, so I should get 57.6 moles of H2O. So what do we do here? All we did was we converted between one chemical in the chemical equation to two other chemicals in the chemical reaction. We just did the molar mass off the periodic table, and then we used the mole ratio or the coefficients to convert between those different chemicals. So again, hopefully this has given you a good start on your homework as we get tackling these in class. So again, long story short, we can convert between moles and grams, or moles of grams in a chemical reaction. Have a great day.